Hello everybody and welcome back to this tutorial. And right now what we're going to do is we're going to take a look at the threaded server in Python 3. Now what we did in the previous tutorial is we saw how we can use both the underscore thread and the threaded library in order to implement different threads into our program and to make our program to be able to execute multiple stuff at the same time. Okay? Right now we're going to take a brief look at how would the threaded server look like. Of course we're not going to code it. It is just simply the same as the normal server, just with the implementation of the threading library that is going to handle each client separately. Okay, so open up your idle right here. Let us enlarge this, and basically first of all we need to import both of the libraries that we'll need. So we will import from socket import everything, and we will also going to need to import threading. Okay, so simple as that. And basically the idea of the threaded server is that each client is going to be handled by a separate thread. So what does that mean? We know that once we create the thread, we need to specify onto which function is the thread going to perform, and also with different arguments to that specific thread. So we know that in order to communicate with clients over TCP connection with socket library, we need to specify the client socket object that is stored somewhere in the memory. So each client will have a different socket object. So already by now we know that the function that is going to be executed by thread will need to take an argument of the client itself. So we would have a function that would look something like this: define handle client, which is going to take an argument of the client socket object. Then we would perform some task for the client itself, so something like that right here. Then we would close the connection with the client, and then we would return from the function itself. So basically you just handle the client, you perform whatever you want to do with the client, whether it is a transfer of files, whether it is communication, or basically anything you want to do with the client itself. You would type it right here in a piece of code, then you would close the connection with the client, and you would return from the handle client function. Okay? Now in order to call that function, first of all let's create the socket object. Af underscore inet is what we're going to use in sock underscore stream. Basically the binding, we will bind the, doesn't even matter, bind your own local host, or basically bind your IP address or the server's IP address, whatever you're using, onto whatever port. In this case what I will do is I will use the port 9000. Then you listen for, let's say, 5 connections, and simple as that you set up your socket. Now the crucial thing right here is that in the while true loop, and the reason why we're using a while true loop is because we need to accept the function, we need to use the accept function to accept different clients at all times that the threaded server is running. So in order to do that, since we're using the TCP connection, we need to specify the first actual variable to store the socket object of the client, and the second variable will store the actual address of the client, which is his or her IP address, and basically the port number that they're connecting on. Okay, and then that equals s.accept, press here enter, and right here you would type the thread that you want to start. Okay, so simple as that. It would be equal to t equals threading dot thread, and in between the brackets we already know what we need to specify. We need to specify the target of the actual function and the argument that we want to parse to that function. So the target equals, basically this target equals represents which function we want to target. We want to target the handle client function, comma, and then we need to specify the arguments to be equal to C. Press here enter, and basically this would be your entire function. Okay, so I will just control C this, or I really can't control C because it is in a while true loop, therefore I need to actually close this program. Yeah, I will terminate it. That would basically be the basic idea behind the threaded server. Okay? Now, there is also another thing that you want to take a look at, which is forking server. Now this is most likely used on Unix. Each client basically, or it can also be used on Windows, but it is mostly used on Unix. And the basic idea is behind that is that it is really similar to the threading, just that in forking server, each client is not handled by a separate thread, each client is handled by a sub-process. So in order to do that, it would look something like this. So import OS, from socket we can import everything, and then we would create the socket object as usual. So s equals socket, and in between the brackets we specify af underscore inet sock underscore stream. We bind our IP address with the port, doesn't even matter. Oops, s.bind. Bind takes exactly one argument. Oh yeah, the actual error is because I'm missing another open and another close brackets. Make sure that you open two and close two brackets, so right here. Okay, so this works. And after you specify the listen as well, what you will need to specify is in a while true loop you would also accept the connections, and you would use the OS library to perform the fork. Now that's managing client and managing the child process, and it would look something like this. So see while true, first of all we enter the while true loop, and first thing that we want to do in a while true loop is to accept the client connection. So C, A, first of all, first C stands for client and the A stands for address. I believe you already know that. So s.accept, press here enter, and what you would check right here is if os.fork is equal to 0, then right here you would manage the client. So you would basically manage client, perform some task right here, then you would close the connection, and then you would os._exit with the 0. Okay? In the else statement, oops, it seems that I have accidentally exited the actual while true loop, but the else statement, let's just hypothetically say that the while true loop was still right here. Basically this would be the parent process, and you would clean up everything and go back to accepting and waiting for more connections, and then you would close the actual connection with the existing client. Okay? But if you want to, you can use both of the ways. I prefer to use the actual threading server in order to accept and in order to manage multiple clients at the same time. Okay? So first of all, I will need to close this because we are once again in an infinite while true loop. Let me enlarge this right here. And another thing that you should know about is the asynchronous server. Now server handles all clients in an event loop. Basically that is what it stands for. And in order to do that, you will simply need to import the select library and also import the socket library. So the asynchronous server would look something like this. You would create the socket object with our regular line s equals socket and then specify inet and sock stream. Then you would perform the code, and then you would have an actual list of clients, not cleanets, clients equal open and close square brackets, list of all active client sockets, and then in a while true loop you would look for activity on any of the existing sockets or on any of the existing active sockets. You would simply just do something like this. In a while true loop you would specify input output error equals select dot select s plus clients, and then you would process all sockets with the input. So for I in input you would use a simple for loop, you would perform some part of the code that you want to do there, and then at the end you would process all socket clients ready for output. You would simply once again perform the output, or pardon me, the for loop in order to do that. Okay? So basically this is not used that much, but you can use it if you want to. Of course, read more about it on the internet. This is just a brief overview in theory how all of that would go. But for now on, let us actually go with and check out some of the different functions that the socket library provides for us. Okay, so basically let us just close this and we'll simply just check something else that we should have checked before, but there are also a bunch of other functions that you can do with the socket library. Instead of just creating the TCP and the client connection and so on and so on, you can simply just perform some simple tasks such as getting the host name of the local machine, let's say. So if you simply just type socket.getHostName, press here enter, what this will output is it will output the name of the machine that the program is currently running on. Now this is just one of the simple tasks that you can do with the actual socket library. You can also try to get an IP address of a remote machine. So what does that mean? It basically means that you will specify the name of the server in the brackets, and then what the function will do, or the function getHostByName will do, is it will retrieve the IP address of that specific name. Okay, so let's say we want to get the IP address of python.org website. We can simply do that just by specifying socket.getHostByName, and in between the brackets we will need to specify the actual server name of the Python website, or the website name, so www.python.org. Press here enter and you will see right here this is the IP address of the python.org. Let us try with a different website, so socket.getHostByName. Let's say we want to go to twitter.com. We want to know the twitter.com's IP address, and we can see that we get the IP address 104.244.42193. Okay? Now there is also a reverse function that performs this, which is the getHostByAddress. What this function will do is it will actually perform our reverse function from the getHostByName. What you would specify in between the brackets is the IP address that you want to get the name for, and what the Python will retrieve is it will retrieve the host name for that specific IP address. So let's try with these two examples right here, since we got their IP address. And in order to do that, we'll simply specify socket.getHostByAddress, and in between the brackets you simply just specify the IP address. So let's try with the first one and see whether we will get python.org as an actual name. So specify it right here, host not found. Let us see right here, for some reason host is not found. Let's try with a different one. So socket.getHostByAddress, and we specify 04.244.42193. Press here enter. Get host by address. For some reason this doesn't want to work, but it doesn't even matter. Maybe I'm specifying something incorrectly. Maybe the syntax is actually different, but it doesn't really matter. We won't really bother with this. There are a bunch of other options in sockets as well that we can use. Basically, socket is a huge library and a huge model. It has hundreds of basically obscure socket control options, flags, and so on and so on. Many more utility functions. It also, instead of supporting just the IPv4 protocol, it also supports the IPv6 protocol. There are also other types of sockets. We also saw sock_dgram or sock_stream, but there are also different ones such as sock_raw and many more. Now, it is often unnecessary to basically directly use these sockets, but other libraries exist to simplify our usage. So for example, we know that the socket is low-level programming, low-level networking, let's say it like that, and there are basically different other modules that allow us to perform everything easily than we would do with this socket library. We will see it in the next tutorial, such as FTP, then SMTP_lib in order to send the actual emails over Python 3, then also, for example, let's say URL_lib which is similar to the requests library. We will take a look at that as well, but more about that in the actual next tutorial. So we'll take a look at the HTTP, FTP, SMTP, and so on. So hope you enjoyed this lecture, and I hope I will see you in the next one. Bye!